So in section 10.3, we're going to solve equations that are quadratic in form. And what I first want us to do is look at a bunch of examples and try and decide, well, what makes something quadratic in form? How can I look at this and say, oh yeah, it's one of those equations, quadratic in form? Well, to try and understand that, what you need to see is kind of a little pattern that's true and exists between the middle exponent and the leading exponent. Now, to help you out with that a little bit, let me work down here with this last one that involves a square root. I'm going to write this a slightly different way. Square root of x I can also write as x to some power. What exponent would I put here? Does anyone know? Not 1. 1/2. So that'd be x to the 1/2. And even though it's not written, what power of x is understood to be here? 1. So this is another version of the formula that I have up here. But what's the pattern here? What's going on with these exponents, this one and this one, this one and this one, that I can look at these things and go, oh, yeah, that's quadratic in form. Perfect. Thank you, Patrick. The first is twice as large as the second. So if you take this one times 2, this one times 2, any of these, and it's not written here, but it's understood that there's a 1, this times 2, you're going to get the leading exponent. So back up here to equations that are quadratic form have a leading exponent that is twice the middle exponent. So the first part of these problems is to recognize that you have an equation that's quadratic in form. Now, if you have an equation that's quadratic in form, then we can make a little bit of headway in trying to solve these things. There's a little bit of a trick that we're going to use in trying to work through them, and that trick's going to involve kind of a substitution. It's a little bit of a workaround. So we got this. I can move on to the next sheet. Thank you. So let's start with this one. X to the 4th minus x squared equals 12. Like a lot of these problems, I'm going to start out by getting 0 on one side. That's mostly reflective of the fact that eventually we're going to have to factor and solve this thing. So if I move the 12 to the left-hand side, I get an equation like this. Is this quadratic in form? Yeah. So quad in form, check. Yes. 2 times 2 is 4, so we're good. But the problem is, a lot of people aren't going to be comfortable factoring and working with these things if they have some kind of a crazy exponent. So here's what we're going to do. Whatever this middle variable term is, just the middle variable part, not this coefficient, we're going to replace that with the letter u. So that's going to be u is going to be the same thing as x squared. Those two are equivalent. Because this is quadratic in form, this term is going to be u squared. And with this substitution, I can rewrite that equation to something that I'll be a little bit more comfortable with. It's going to look like this. U squared minus u minus 12 equals 0. Thank you. X to the 4th. Thank you. Yeah, sorry. This is going to be a little bit easier to work with. In fact, I'm hoping that you can factor this. How would this factor? U into U. plus 3 minus 4. Yay. And from here, we can read off the solutions to this problem, right? It's going to be u equals what? Negative 3 and positive 4. Now this little trick up here was kind of a workaround. It just avoided us having to work with and factor something that involved, fourth powers and other stuff like that. So it's just kind of a trick to get us to this point where we've got a more reasonable equation. We've got essentially, since u and x squared are the same, let me go back now and finish solving for x, which was our original problem anyways. X squared equals negative 3, or x squared equals 4. Okay, that I think I can solve. What would you do to solve x squared equals 4?
Square root it.
Yeah, take the square root. So, square root on the left-hand side, square root on the right-hand side. What else do I need here? Ah, well done, plus or minus. So it's x is plus or minus 2. And I can do the same thing over here. Square root plus or minus square root of negative 3. The only difference is that I have to deal with that negative under the radical. Plus or minus the square root of 3 becomes, plus or minus the square root of 3 times I. You might want to write that with the I out in front. That way it doesn't look like, it doesn't get confused with the I being under the radical. So overall, you've got 4 solutions. You have x equals I times the square root of 3, negative I times the square root of 3, 2, and negative 2. So yay, 4 solutions. The trick that made this work was our little substitution that got us around the difficulty of working with a 4th degree polynomial. As far as an exam is concerned, you can leave your answers like this. Newton seems to be sometimes fussy, sometimes not. Sometimes it accepts the plus or minus, sometimes it gives me a hard time. Not sure. Patrick, you gave some misgivings about something. No? Not looking all right?
Newton always worked with plus or minus for me.
Okay.
And I did 10-3 on Newton already, so.
Okay. All right. Good deal. Anything else on this one? Looking good at that first example? Okay. Looking real good? All right, good. I'll make them harder then. All right. Actually, I'm kind of following along with problems that I just pulled out of Newton. So I'm trying to make this look as much like your homework as possible. 6x to the 2/3 minus x to the 1/3 equals 12. Like the last one, I'll start out by moving the 12 to the other side so that I get 0 on one side. So the question is this quadratic in form? How can I tell? There you go. Thank you. It's too bad that the microphone probably couldn't pick that up. All right, yeah, the lead coefficient is twice the middle one. So, yeah, we're in good shape. What's my substitution going to be this time? What am I going to let u equal or take the place of? Well done. Thank you. It's just the middle variable term. Don't worry about the coefficient. So u equals x to the 1/3. Automatically, u squared is going to be x to the 2/3. If this is quadratic in form, you don't have to worry about the actual calculation of this, although it might be helpful to see this. Stephanie, let's put these terms in to this equation. What's that going to result in? What's my new equation going to be? 6u squared. Perfect. 6u squared minus 12 minus u equals 0. So now you guys have a dilemma. If you think back, we've got 3 methods that I've emphasized as far as solving quadratic equations. What were they? There was quadratic formula, good, factoring, and the square root property. All right, completing the square, you can do it that way, but I don't like it. It's like, yeah, fingernails on a chalkboard. It's just painful. So the problem with factoring is that this isn't the easy one to factor, is it? How come it's not an easy one to factor? Yeah, because the leading coefficient is not 1. Thank you for not saying your instructor is mean. Okay, so because that's not a 1, then you've got a lot of work to do. So tell you what, I'm going to show you both different approaches to factoring this, or just to solving this, and then you figure out what you like best. Now, I'm not going to go through this that slow that maybe you want to take notes, but here's our 2 possibilities. The first one is factoring. So you multiply the outside numbers. 6 times negative 12 is negative 72. You need to find 2 numbers that multiply to negative 72 and also do what? Add to negative 1, right? The coefficient here. Well, those 2 numbers would be negative 9 and 8. Okay, yay. So what do you do with those? Well, you take that number here and you split it up. You split it up into negative 9 plus 8. And then you can factor by grouping because you've got 4 terms. So it looks like this. Now there's an important thing that you should look for when you're doing the factor by grouping. These 2 binomials match. You factor out the 3u from the first 2, the 4 from the second 2, and these match. Why is that important? That's what they're supposed to do, yeah. That's a good answer. That's what they're supposed to do. If they didn't match, then you couldn't factor out the 2u plus or 2u minus 3. You couldn't factor out a GCF because there wouldn't be a GCF. If you get here and they don't factor, there's something wrong. So I factor those, and then what? Well, then I've got this times this equals 0. So one of these 2 things had to be 0. And you just solve each of those, and you get 3 halves and negative 4 thirds. Wow. Get out the oxygen bottle. Now that's just your solution for you. What if we looked at it with the quadratic formula? So let's try it a different way. So here's the quadratic formula approach. We'll plug in A, B, and C. I always do that with parentheses. Let's slide down a little bit. The double negative will simplify. I'll get 1 minus 24 times 12 is going to be 288. But it's going to be a negative 288, so the double negative becomes a plus. And the nice thing down here is we get 1 plus or minus the square root of 289. What's special about 289? Good. Square root of 289 is exactly 17. It's a nice, perfect square. It's a number that's on your left-hand side board. So that, oh yeah, 289. That's 17 squared. So that allows us to keep going. We can say, all right, well, let's take the square root of that and get 17. And now you've got 2 possibilities. 1 plus a square root, or 1 plus 17, or 1 minus 17, both divided by 12. And then both of these simplify, and then simplify some more. And guess what? That exactly matches what I had over here. So you get 3 halves and negative 4 thirds. So it's up to you which way you want to solve this one. We're gonna have to do some more work with this and finish it up. But right now, let's keep track of where we're at. We're trying to solve this much right here. And we figured out that the two solutions are u equals 3/2, and u equals negative 4/3. So, one more remark about this stuff. I was never very good at factoring these things. In fact, I hated it. I really did. And I'm sure a lot of you guys feel somewhat the same. You just don't like factoring these things. You don't have to. You can use the quadratic formula. It doesn't hurt. You get the same answer. The only bummer about the quadratic formula is that, I don't know, you tell me, what's kind of a bummer about the quadratic formula? That's long. It's easy to make a mistake. So, yeah, the quadratic formula is not utopia. It's not a perfect solution, but it's nice. The problem with trying to factor is you could spend a lot of time and effort factoring and find out, you know what, it doesn't factor, it's prime. And guess what? If you spend all that time factoring and find out it's prime, then you're back over here, you got to use the quadratic formula. So it's like, well, how much effort do you want to put into factoring, knowing that that might be lost effort? It's kind of up to you. If you want to kind of split the difference a little bit, here's a little trick you can do. Right here, I knew this problem was going to factor. Right there. If you're solving the quadratic formula, you could tell right here that, you know what, this problem would have factored. How? This is a perfect square. You can take the square root of that easily. All right? So the trick is, if you want to decide, gee, can this factor? Then calculate this number underneath here, the b squared minus 4ac. If it's one of those numbers on the left-hand side board, one of those 20 perfect squares, if the discriminant equals one of those numbers, then you know what? It'll factor. So if you want to factor it, go ahead and factor it. If you don't, that's fine. Come back over here and do the quadratic formula. One way or another, you need to get these two solutions. Okay, big digression. So, suppose you factored it, 2u minus 3 times 3u plus 4 equals 0, and we get these two solutions. U equals 3/2, and u equals negative 4/3. That's not our solution. Why not? Yeah, this is a solution to u. That's a solution to this equation. I need a solution to this equation up here. So I need to figure out, well, gee, what does this mean in terms of x's? So what would be my next step then? To solve this in terms of x? Plug in where? There you go. Perfect. U equals x to the 1/3. So I'll rewrite that as x to the 1/3 equals 3/2, and x to the 1/3 equals negative 4/3. All right. Now at least I have a shot at solving this. So let's see. Something to the 1/3 power is like taking what kind of a root? Cube root. So if I wanted to solve here, if I want to get rid of a cube root, what would I have to do? Yeah, cube both sides. So we'll cube both sides here, cube here, and cube here. And I'll get x equals, well, 3 cubed is 27, 2 cubed is 8. So that's one of my solutions. Yeah, you could write it as 3 3/8 as well. Now, in general, I'm probably not going to take the time quite often to write this as the cube root and then cube both sides. The quick way to think of this, to solve here, is to raise both sides to the reciprocal power. So in this case, I've got x to the 1/3. What's the reciprocal of 1/3? Three. Yeah, so you'd be cubing both sides. So the quick thing to do in solving these things is raise both sides to the reciprocal power. Let's see why that works. I have x to the 1/3 here equals negative 4/3 here. When I cube both sides, I end up with 3 times 3 when I remove the parentheses. 3 times 3 is 1, or x to the first power. What do I get when I cube negative 4/3? Thank you. Negative 64 over 27. Yeah. Yay. Those are your two solutions. No, great question. The u squared, no, we don't have to do anything with it. We did use the u squared here after we did our substitution, but once you factor, the u squared is gone because you split up that u squared into this times this, so you've got a factor of u in each of these, and we never really needed the u squared after that. So yeah, the u squared is all done, and we're all done. We got our two solutions. That one was a little bit more intense. Sorry, it was kind of a long example. To kind of recap, we realized that it was quadratic in form. So we said, okay, well, we can make our little u substitution. That's this part right here. We made that u substitution. That gave us a quadratic equation. Solve that quadratic equation any way you want. Square root property, factoring, quadratic formula. Once you have the solutions for u, go back and solve for x. So in the case here, we end up with x to the 1/3 equals 3/2. The quick thing to do is to raise both sides to the reciprocal power, and it's the reciprocal of this number, whatever that is in the exponent. Okay, that was a long one, and I think I want to be done with this one, at least for the moment. We'll come back in a little bit, and I'll show you how to check that on your graphing calculator. You can check it and say, hey, wow, I got it right, and feel really good, and then go home and cry beady beady beachy, right? All right, cool. We went over that one, didn't we? All right, good. Yeah, beady beady beachy means it's Latin for I came, I saw, I conquered. So. Well, Italian is a Latin-based language, so I mean they are going to have some similar words and phrases. One of my doctors has a tattoo that says, basically in Latin it says, I can't live without you. But I think he got it for his first wife. I'm not Whoops. Yeah, it's like, oh, okay. All right. Yeah. He's lucky it's Latin. Not many people can read it, I think. Is this quadratic in form? Yes. Courtney, what should I let u equal in this particular problem? Perfect. U is always, once it's quadratic form, u is always going to be that middle variable term. Notice that she didn't give me negative 3x to the negative 1. It's just the x to the negative 1. Well done. So u squared equals x to the negative second. That kind of completes our factorization, or at least our substitution. So that becomes 4u squared minus 3u minus 1 equals 0. We've got another quadratic equation. So your choices are kind of the same. You could factor, or you could use the quadratic formula. On this one, let me kind of guide us towards factoring. And I'm not going to do the long way that we did the other time. I'm going to do something called guess and check. Now, generally, I'm not a fan of this because I always felt like, was it prime or was I just not clever enough to figure it out? But there's something special about this one that makes it a little easier to do guess and check. It's the -1 here at the end. How do we get this end term from our foiling? It's going to be first, outside, inside, last, right? So this has to be the product of the two last numbers. Yeah, 1 and -1, right? There's not much choice. One has to be positive one, one has to be -1. So, okay. Well, what do you put here? We need some things that multiply to 4. But fortunately, the list is pretty short, right? 2 and 2, or 4 and 1. So if you try, and let's get this wrong to begin with. If I try 4u and u, let's FOIL that out and see what happens. It'd be 4u squared plus 4u minus u minus 1. And what's 4u minus u? 3u. But I need -3u. So we were close, but not quite. What change do I need to make? Yeah, 4u plus 1 and u minus 1. Basically just switch them up. So if you're comfortable doing that, I mean, you don't have to do it the long like we did earlier. But I don't know. I have sympathy for you because I was terrible at factoring these things. I would literally use the quadratic formula, and then once I had my solutions, figure out how it factored. So we get two solutions from this, though. What's one of them? What's the one you can read off? Good. U equals 1. The other possibility, you're going to have to solve a little bit. 4u equals -1, so u equals -1/4. So I get two solutions to the quadratic equation, but that's not my original equation. All right, so let's go back and finish solving then. So let me take these up here. I have u equals -1/4, and u equals u equals just 1. How do I solve? What do I do from here? All right, so let's first put in u as x to the negative first. And then what? Well, I think Patrick gave us a suggestion. Raise these both to the reciprocal power. But here's the trick question, or the tricky question. What's the reciprocal of -1? All right, well, there's nothing wrong with that. So the reciprocal of -1 would be 1 over -1. How does 1 divided by -1 simplify? -1. So basically, -1 is its own reciprocal, which is a little strange, but it's okay. It'll work out really nice. Given all the ways that there are to solve this problem, this one's the fastest. Yes, sir. I hope so. Yeah, let's just. Well, actually, what I meant to do earlier was check the sound here. Yeah, because if this isn't recording here, then it's kind of it's not even letting me check it now. Come on. Go to the window button. Settings. Okay. Devices. System. All right. Sound. Choose your input device. Logic. Oh, okay. Yeah. There we go. Whew.
When you say reciprocal, you mean the opposite.
No, that would be the negative. The reciprocal is when you take 1 over something. So, for instance, so number and reciprocal. So, quick primer on that. If my number is 5, the reciprocal is 1/5. If my number is 2/7, the reciprocal is 7/2. So, there's a relationship between the number and the reciprocal. Now, as far as -1 is concerned, Negative 1 is its own reciprocal. When you take the reciprocal, it's not going to change the sign. But the nice thing is that when you multiply reciprocals, 5 times 1/5, 2 sevenths times 7 halves, negative 1 times negative 1, what's the product? Yeah, no matter what you do, you're always going to get 1 when you multiply a number and its reciprocal. And that's the important thing here. Negative 1, negative 1, negative 1, negative 1. Negative 1 times negative 1 gives me x to the first power. Yay. What's the reciprocal of negative 1/4? Nice. Tell you what, let me do this one out slowly. When I take the reciprocal, one way to calculate it is to take that number and make it the denominator of 1. So 1 divided by your number gives you the reciprocal. Dividing a number 1 by this fraction is the same thing as multiplying by negative 4 over 1, which gives you negative 4. All right. So that's kind of the long way. We didn't necessarily need to go through all that. Over here, negative 1 times negative 1 is 1. What's the reciprocal of 1? 1. Yeah. So I get two solutions here. 1 and negative 4. Why is which one negative?
Like x equals 1.
Why isn't it negative? Because when you take the reciprocal of 1, you just get 1. So when you take the reciprocal of a number, if I add a number like, let's say 4, then to get the reciprocal, I'll divide 1 by that number. So if I wanted to do the same thing with 1, if I take 1 divided by that number, it's 1 over 1, which simplifies to 1. So it doesn't change the sign. In a similar manner, if you add negative 1, if I took the reciprocal of that, that's 1 divided by this. So neither of these two numbers actually changes when you take the reciprocal. 1 and negative 1 are their own reciprocals. Dallas, did that answer your question? Sure. Which is polite speak for, I'll figure it out at home. All right. If there's some more I can answer on that, though, let me know. Okay. All right. Fair enough. How are we looking on this one? There's a lot going on with this stuff.
I don't know how I feel about the 1 over 1/4. It looks a little like kind of trashy.
It does, but then we simplified it to take the number and multiply it by the reciprocal of the denominator. 1 times negative 4 over 1 is just negative 4. So if you can get that without going through all those gyrations, that's fine. You can jump straight from here to here. I got no problem with that. Okay. One thing that I do promise you is that the problems I have on the test are going to work out pretty gently. They're not going to be as tough as some of the problems that are in the homework. But I got a little remedy for the homework as well for you. Anything else on this current example? I'll give you a choice. Do you want to try one, or do you want me to show you how you can double check your answers? Well, you're eventually going to do both, so it's just a matter of order. You want to try one, or you want me to show you? Let me show you how to check your answers. That way, as I walk around, if you've already solved it, you can try checking your answers. So if you have a graphing calculator or a calculator at all that stores things, pull it out. If you'd like to borrow one, come on up. Keys, credit cards, pictures of dead presidents with large denominations.
Is Trump one yet? Oh, wait.
In his own mind, perhaps, but
JFK is.
there you go. Fair enough. I guess your earbuds too. Definitely coming back with those.
Whole package, man.
During the break, because it's tucked away someplace. I'm not being mean. It's just, huh?
Why'd you do that? You know I come to class late every day.
All right. So on the home screen, let's go back and we're gonna check our answers to this problem. Probably one of the nastier ones that you're gonna run into. So our answers were 27 over 8 and negative 64 over 27. So let's start with this one. So take 27 divided by 8, and then just above the on key, there's the store button. Store that in X. All right, so 27 divided by 8, then hit the store key down here. Stow, right? Stow. So store it in X, which is right here next to the second button. And you should get something like this. 27 divided by 8, store into X, and then press enter and it'll give you a decimal value.
I don't got X, man.
You should have upgraded when you had a chance. Lisa, you good? You got that? Is it showing up on your calculator? Okay. Let's type in one of these two equations, and it doesn't matter which one we use. If we use this one, if we type in 6x to the 2/3 minus x to the 1/3 and press the enter key, then I should get 12. So let's try that. 6x. If I want to raise to a power, I use the key above the division sign, divided by, or raise to the x, to the 2 divided by 3. If you're doing this on an old TI-83, you need to put that 2 over 3 in parentheses. And then exit the exponent. So hit the right arrow key. Minus x raised to the 1 divided by 3. And then use the right arrow key to exit the exponent again. If I press enter and everything worked right here, what should I get? 12. So, drum roll please. There we go. Bless you. 12. Yay! Cool.
What would have happened if you guys didn't get the right answer?
If you didn't get the right answer, suppose I had a different number.
You got the wrong answer.
If I get the wrong answer, suppose I had an 8 here. If I tried this with an 8, then instead of getting a 12, I'll get something else. I got 22. So 8 didn't work. So it would have been egg on my face. The other answer that worked was negative 64 divided by 27. Make sure that when you put in the negative 64, that you use the minus or the opposite key on the bottom of your calculator, not the subtraction key. If you try putting it in with subtraction 64, it's not going to like it. Store in X. Then you can go back, scroll back, and pull up a previous calculation. And bam, it works again. So, cool. Now you can check your answers. Is that a good trick?
Yes.
Yes. All right, good deal. All right, your turn for one.
I have a calculator.
No, you will not need a calculator on this one. It's convenient, you can check your answers, but you don't need one. All right, so here you go. X to the 2/3 plus 8x to the 1/3 plus 15 equals 0. And I think I have one of those manual pause buttons handy. There we go. I'll walk around and try to help you out. If you have some questions, try and flag me down. If you finish it, try checking your answer with your calculator like we just did. And as usual, help your neighbors. This is a group effort. Wow. Yeah. Yeah. He's losing the crowd already.
So wait, we do the
want to do a U substitution, then solve it, and then plug back in for x, and that's when you're going to do the reciprocal powers.
It's all good. I'll be lost for like 15 minutes.
Try.
It's gonna be.
Start with your substitution.
Quadratic formula.
Okay. No, no, no. That's spot on. Good. So now rewrite the equation in terms of U. Okay.
That's your soul.
So cube full size equation. This is essentially what that means. Well, you cube. You're going to do it the whole. Well, essentially what this is it's the cube root of 3. Or cube root of x.
Okay, so say that then. What? I found an answer and everything is wrong. I did. You really will pause. I thought it was.
Okay. Well, if you had to, you could use a quadratic formula. Otherwise, it'd be a plus. So maybe that'll make it easier. So let's start out like this. Right, so now we need two numbers that multiply the 15 and add 2. There you go. Except to be x to the 1/3. U is x to the 1/3. And that's going to make it easier for you to solve. Because the reciprocal of 1/3 is going to be nice and easy. Common solve. Yeah. Sounds pretty fun. It was.
Sorry to hear.
Okay, so now you can solve this. Solve for you. What do you need for you? What are the two choices? Okay, you got a quadratic equation. So it's this times this equals 0. So either this equals 0.
I know they are. That's why.
Like $15 is hard. Oh, that one? Oh, those I don't know. How about talking about Apple charger get for your phone? Those are like $15. Lucky me, I only got fresh out.
Were you able to check your answers with what we did a few minutes ago?
Oh yeah, yeah.
Okay, so right here, remember U is taking the place of x to the 1/3. So this is really x to the 1/3.
Charged it in my phone.
The trick was to raise both sides to the power. Yeah. Cube. 3 times 1/3 is just 1.
Like $25.
So try solve the other one and see if you can't check your answer.
I'm flabbergasted. Notes can't help you now.
Ah! So fair.
I'm learning things, I know. Wow. Oh, I started as 2 to see if it was actually
does math exist? Math should not exist. Then when you're gonna basically I'm sorry, they also get there. When you test
What you're getting is essentially a rounding error. Okay? So 1e negative 12 is really a number in scientific notation. All right? 12 is 1 times 10 to the negative 12, which is 0.0000. So it's basically it's extremely small. What you're getting is a little rounding because your calculator is not working exactly.
Okay, I have one more question. How do you like how do you go up without having to type in all that again?
The second key is the integral.
Okay, thank you.
Yeah, but I don't know where else it would be, and I have homework to do tonight, so I kind of need it. No, I didn't charge in psychology. I charged at my third hour. That means I'm not gonna be able to charge it for 2 days. I just need this. Oh, it's for your head. It's the actual plug-in part. That's the only part that I need, and I don't know where it is. Like, I thought I put it away after third hour, so I can't really gut my bag anymore. Like, part of it is
So you take the first one in quadratic form and
I got it for Christmas like years ago.
okay.
I want to get one.
I like it.
And then if it is, you replace the second variable. Right. And then this one. Let us know. And then you just rewrite it. So like
You said
so this would be u to the 2, right? Plus 8
Maybe I dropped it in my car.
plus 15, right?
Maybe.
And then you just factor it however you want, like
She's under all this.
here. I don't know where it's at.
this one.
Yep.
That. I lost
I got
this part of my.
confused at the end.
Okay, because you have to move it to the other side.
But you're not done. Oh, there you go.
And
Question.
then
I'm sorry, I didn't get by you. Did you get it?
for the x. So do I.
That's right. Yeah, good job. Oh my, that was a long pause. Okay, so just to kind of recap here, this is quadratic in form. So you're going to let u equal that middle variable part right there. U equals x to the 1/3. So that means u squared equals x to the 2/3. That's going to make up our substitution. Thank you. U squared plus 8u plus 15 equals 0. And this factors as u plus 3 times u plus 5.
Did you do guess check or did you do
Well, because the leading coefficient here is 1, I just look for two numbers that multiply to 15 and add to 8. So I get two solutions. -3, and -5. Bringing those over here, u was taking the place of x to the 1/3. Let me go back and solve in terms of x's. All right. Yeah, I want to raise both sides to the reciprocal power. So in this case, the reciprocal of 1/3 would mean cubing it. That gives me x equals -27 or x equals -125. If it was 1/2 power, then you'd be squaring both sides. Yep. How many people got that one? Well done. Well done. Okay. Let's keep going. Only a few dozen more. All right, maybe a little bit less than that. That was a long problem. Yeah. 8. X plus 3. X plus 3. So x plus 3 squared plus x plus 3. Whoops. Thank you. -6 equals 0. This actually looks worse than it is. Is this one quadratic in form? Yeah. If you look at it carefully, there's a 1 here. 2 times 1 is 2. So it is quadratic in form. What should I set u equal to in this particular case? Yeah. X plus 3. The middle variable term. So there's your u right here. U equals x plus 3. U squared is x plus 3 squared. Okay, that makes sense. Courtney, what's the quadratic equation I get from this? Perfect. So those factors are the +3 and -2. Joe, what are my solutions here for you? Perfect. -3 and 2. Those I hope you can read right off. We're not quite done though. Got a little bit more to work on with this one. Then what? Well, I get u equals -3 or u equals 2. Suggestions? Now what? X plus 3 equals -3 or x plus 3 equals 2. Wow, man. There you go. Okay. Looking better. What do I have to do to solve for x? Subtract 3 from both sides, and I get x equals -6. Or if I subtract 3 from both sides here, I get x equals -1. That wasn't so bad. In fact,
that was easy.
Yeah, cool. Yeah, it actually worked out pretty nice. I think. I don't know. Was that an easy one? Yes? Okay.
The other way that you could have technically done this one rather than using u is
Yeah, if you wanted to FOIL it out and then collect like terms and then factor it again, yeah, you could have solved it that way. That way works in this particular case because this is essentially a quadratic equation, but yeah. No, I wouldn't subtract points. If you did it that way on a test, fine. I don't know about extra points. I should get extra points because it's tougher for me to grade those because then I got to rewrite it an answer key or something. All right. Let's see. A couple more here to go. Did you guys get my email about the computers? Yes? All right. All right.
I think you addressed it singular.
Well, yeah, I might have. Let's take a look at this one. August, this is kind of in response to your question just a minute ago. No, actually, Georgie. Sorry, my bad. Georgie, you had one question, something like this. Now, we looked at something like this earlier, and I rewrote the middle term. Do you remember what I did with the middle term? Instead of the square root of x, I wrote it as x to the 1/2. So that's x to the 1/2 power plus 20 equals 0. And now, all right, well, this is quadratic in form. What's u going to equal? X to the 1/2, and then u squared is just going to be x. You guys want to work on this one? All right, let's see what you can do. If you're playing this game at home, then try and solve it before we unpause.
I did.
So it's
-4 and -5. Multiply the 20 and add to 9. Okay, so the equation becomes u squared minus 9u plus 20 equals 0. This factors as u minus 5 times u minus 4 equals 0. And from that I get two solutions to my quadratic equation in u, 5 or 4. But I didn't really set out to solve an equation in u. I wanted to find solutions for x. So let's recall that x is really, u is really x to the 1/2. So I can write this as x to the 1/2 equals 5, or x to the 1/2 equals 4. So let's finish solving those up here. X to the 1/2 equals 5. What's the reciprocal of 1/2? So if I square both sides here, I get x equals 25. Or when I square both sides here, what do I get? X equals 16. So 16 and 25. Technically, you got to check these answers. Make sure that the square root of 16 is 4, square root of 25 is 5. If I had a negative number here, then it wouldn't check in these equations. But here we're okay. So I got two solutions, 25 and 16. Yay. All right, cool. Thank you. One last one, because I know that your patience and your energy are near an end with this section. I know. I do the jokes, okay? Come on. All right. Last one. And it might help to have out your computer on this one. We will lean on it a little bit. Eight x to the 4th minus 42 x squared plus 40 equals 0. This one came directly from Newton. And when I saw this, I was a little less than happy. So let's see why. Now, if you were asked to solve this, there's really a couple things you could do, a couple ways you can approach this to make this equation a little bit easier. Not a lot, but a little bit. Let's start by looking at all the coefficients here. Do you notice anything about the coefficients? There's a GCF. Somebody said it. There's a GCF. What's the GCF here? Not 4. 2. All right. Just throw out a bunch of even numbers. One of them will stick, right? So here's what we're going to do. We're going to divide everything by 2. This by 2, this by 2, this by 2, and this by 2. Why? To make the problem simpler. This is going to be 4x to the 4th minus 21x squared plus 20 equals 0. So, okay, the numbers are a little bit smaller, regardless of how you proceed. If you're using the quadratic formula or if you're factoring it, at least it's a little bit better. Not a lot, modest amount. But here's where I'm going to open up what my student this morning termed Pandora's box. Let's go to the internet and open up a new page. Your favorite search engine is Google, and type in quadratic equation solver. The second option down that you should get should take you to Symbol Lab. Math is fun. Say it with enthusiasm, okay? All right. Math. Well, that's across the pond in England. They consider maths plural. I don't know why. You don't take a baths. Why is there maths? I don't get it. All right. So let's take a look back at our problem. Is this an equation that's quadratic in form? Yes, it is. So what am I going to let u equal? Somebody I haven't heard from yet today. I like it how everyone suddenly gets interested in their shoes when I ask for a volunteer. Pat? Yep, u equals x squared. U squared equals x to the fourth. Steve, with these substitutions, what's my equation become? What's my new equation when I substitute those in? 4u squared. Good. So solving this looks a little bit friendlier than what we started out with, which was this above here. So we made a little bit of progress, but here's where I get a little unhappy with Newton. These problems are long enough and tough enough without you having to mess with an equation that's just not that friendly like this one. You've got two choices. You got to factor that one, or you have to use the quadratic formula. Factoring means you multiply 4 times this is 80. Find two numbers that multiply to 80 and add to negative 21. Negative 16 and negative 5. That's a long ways to work on this. What I promise you is that on your exams, I'll give you something that's not nearly this tedious. Until then, let me try and make your homework life a little bit easier. Let's go back to our symbol lab and type in 4u. Now, I think if you hit the squared button there you go, 4u squared minus 21u plus 20 equals 0. So there's our equation. And when you're ready, hit the magic button, and bam. Wow, that's pretty cool. You got your two solutions here, u equals 4 and u equals 5/4. Booyah, that's cool. What's that? You're right, you won't be able to use this on the test. But, yeah, that's the thing. I will not give you equations this hard on the test. I mean, what I'm worried about in you working these things is that you'll make a mistake here, there, or someplace because the problems just get so long. I mean, this is really getting to be a long problem when you add in either all the time in factoring this or all the time in using the quadratic formula. And it's a pain. You can make a small mistake. Even though you know what you're doing, you can make a small mistake and end up with the right answer, and it sets you back. So, bummer. Okay, so we get two solutions, right? U equals 4 or u equals 5/4. You still have to know what you're doing. We're still not done here, right? I mean, that's just a solution to the quadratic equation. Then what? Got to solve for x. All right? Thanks, Michelle. How do we solve for x? What am I going to do next? X squared equals 4, and x squared equals 5/4. Thank you. Here's a good question for you. What's the reciprocal of 2? 1/2. So the trick here was to raise both sides to the reciprocal power. So essentially it's raise both sides to the 1/2. But something to the 1/2 power is like what? It's like a square root. So I need the plus or minus there. X equals plus or minus. What's the square root of 4? 2. Now there's nothing wrong with just doing the square root. X squared equals 5/4. I'll take the square root on both sides. So square root here, plus or minus here. And I'm not sure what Newton's going to want, if they'll take plus or minus the square root of 5/4, or if they're going to ask you to break it up. Square root of 5 over square root of 4, or better yet, plus or minus square root of 5/2. So I can't guarantee on what they're going to look for. But when the problems get a little bit too messy or complicated, I really don't have any issue with you, going out to Symbol Lab or something like that and helping yourself out a little bit. Yeah. Okay. Hopefully that'll make your homework life a little bit easier this week. We good with that one? I think I pretty much said all I want to say about section 10.3. So, cool.